Hello, the purpose of this video is to explain and illustrate the testing process to put in place in order to test a Simulink model starting from a test model built with MaTeLo. This software implements a method of model-based testing and has been developed by the software provider All4Tech. The sequencer of tests used to execute the tests on the Simulink model is the Stimulus Profile Editor of Veristand developed by National Instrument. The first step consists in adapt the Simulink model to allow the communication with Veristand. It is necessary to replace the inputs and outputs of the Simulink model by specific blocks provided via the National Instrument toolbox. To access these blocks, you only have to type the command line "ni Veristand block" in the Windows command window of MATLAB. From then on, a window is opening, and it contains the blocks to substitute to use Simulink model. You also have to specify the input and output variable types accordingly with the signal used in the Simulink model. For this, I advise you to use conversion blocks between inputs, outputs and the model to test for a data type system simpler and faster. For this demonstration, all the inputs, outputs are doubled. The second step consists in creating a project with Veristand or to update one of your existing project with the Simulink model. Once Veristand is opened, you must select a project or create one. The project window opens. Select the reference system definition file, then the definition system file corresponding. The System Explorer window opens. Select the simulation model reference, then add simulation model. Select the Simulink model that you wish to test via the folder icon of the path window. Once this operation done, the input-output reference of your Simulink model is updated or created into your Veristand project. You can verify this information by opening the folder's inputs and outputs. The inputs and outputs of your model should be referenced. The Simulink model information are saved in the system definition file. This file will be used in the following presentation by the MaTeLo software to do the mapping with the Veristand project. This file is saved into the project directory of Veristand. In this case, it is located in the project directory of the folder National Instrument Veristand 2012, located on the C disk into My Documents. To export your test cases with the NIFSEC format, select File, Export, Test Case, Export Test Cases. Fill the window with the paths as specified. Veristand file, it corresponds to the system definition file from Veristand used to create the data in MaTeLo. MaTeLo file, it corresponds to the test case created previously. Save directory, folder where the test sequence will be saved. Click on Next. Greater than a file with the NIFSEC format is created in the specified folder. The data and value used in the real-time sequence are the same that the information contained in the test plan generated in MaTeLo. This definition file will be used in MaTeLo to create, in an automatic way, the inputs and outputs data types used in the MaTeLo library, in order to model the simulations and verifications of the test models created for the system. To create these inputs, outputs in MaTeLo, open the modeling tool, then the project on which you are working on. Select the menu, File, Import function. A window opens. In the folder Test Bench, select the Veristand icon, and click on Next. In the new window, select the definition file previously created as well as the location wanted to create these inputs and outputs proper to MaTeLo. From the definition file, MaTeLo generate two files in the directory selected. To use these data, you just have to import these files. Select in the menu, File, Import function. Then select the Inputs icon. You now have to choose the file with the extension inputs in the folder previously created. A new window opens. This interface allows the management of potential conflicts between the data currently in the library and the new ones that you wish to import. For the data already referenced under the same label, you can update those already present in the library or keep them. For this demonstration, the library data has already been imported prior to the video, so I won't go any further in this operation. The next operation is identical but concerns the outputs of the system. Once all the data present in the library, you can begin the modeling process. To associate an input value, you just need to select the transition on which you want to model the operation, and then associate the input variable to the transition under the Properties tab. To modify the value affected, you have to modify the distribution type. It exists three types of distributions. Fixed to affect a value defined by the user. Rectangular, you have to define a range of value for the input. Gaussian, you have to define a mean value and a variance. You have to associate a requirement to a transition. Select in the Requirements tab, the requirement to associate, then drag and drop it to the Requirements window of the transition. Proceed the same way to associate a treatment function to a transition by selecting the Treatment Functions window. Inform the input and output variables necessary to the selected operation. The operations located in the directory pretreatment will be affected before the affectations of the inputs present in stimulation and the output in verifications. If you affect in the operation the calculated value to an input, you won't be able to specify a fixed value to this input at the transition level. For the operations of verification associated to the outputs of the library, you have the possibility to create an expected result in an automated way that will compare the result of a global variable used in the test model to the expected result. You can also specify a fixed value or an interval of comparison. To create the test cases from the test model, select the Generation window via the button on the top left. Select the default strategy or create your own strategy. Select the substates of the model you want to parse or include in the generation. Select the appropriate algorithm to fit your test strategy. Click on the Generate button. The test cases appear in the main window of the generation perspective. You can modify the type of display by double-clicking on a test case and then by selecting the type of display. In this example, the display chosen is HTML. To associate a test case or several to your project, right-click on it and select Add to Project. In the test report, the information that are displayed under the Stimulations sidebar match the inputs. You can actually see its name and value. The information that appear under the Verification sidebar match the outputs. You can see the name and value of it as well. The information that appear under the Requirements sidebar match the requirements associated to the transition of the test created. The numerical values in the test report will be the one used to instantiate the test script function parameters defined in the MaTeLo library, accordingly to the association of the parameters done on the transitions. The test report summarizes the stimulation and verification actions done in the test model, as well as the values affected or computed by the algorithms. The reference with the Veristand project is maintained by MaTeLo during the test case generation. This way, during the test case generation, you can visualize the location path of the variables from the Veristand sequence project, as well as the association done with sequence parameter. This referencing is essential to execute the test sequence. You have to create a test profile. This test profile allows the user to control the Veristand project environment. Open Veristand in an automated way, deploy the definition system file and call the test sequence created. You can create and define some control parameters. The next part of the video shows the execution of the test sequence on the MATLAB model. Click on the Run button and be patient. At the end of the execution of the test profile, a report is automatically created. It indicates the status of the steps passed or fail, as well as the value of the control parameters. When the test sequence is executing, you can see the evolution of the input and output variables through the workspace. The execution report indicates the status of the steps, passed or fail, as well as the value of the control parameters.